Welcome to the Deep Dive. We're here to give you that instant edge, making you well-informed fast. Today, we're tackling a beast, the Artificial Intelligence Index Report for 2025. It's pretty much the definitive guide to what's happening globally in AI.
Yeah, and our mission isn't just to skim it. We're doing triage, really. There's so much noise, so much hype. We want to cut through that and pinpoint the truly critical trends right now. Think geopolitics, think real-world deployment. Some surprising stuff in there.
Absolutely. And what makes this report so valuable is that it tracks things over time. It's longitudinal. The co-directors even say, AI isn't just about potential anymore. It's about what's actually happening, measurable changes.
Right, we can see the trajectory.
We have the data now to see how fast things are moving, but also, interestingly, where that progress is maybe hitting some unexpected walls.
Okay, so let's jump right in with speed, with the velocity of this thing, because there was one statistic, it just leaps out. It really defines where we are. It's about AI solving complex coding problems, real-world stuff. Oh, that one. Yeah, it's genuinely staggering. You're talking about the SWE benchmark.
SWE bench, right.
Yeah, basically it puts the AI in the position of a software engineer. Fix this bug on GitHub, do this complex code maintenance. So in 2023, the success rate for models was, wait for it, just 4.4%. Pretty low.
Okay, 4.4%. And fast forward just 1 year to 2024. What are we seeing?
The top models now solve 71.7% of those problems.
71%.
Yeah, that's a 67.3 percentage point jump in 1 year. It's kind of mind-blowing. And the real insight here, I think, isn't just the number itself. It's that AI seems to be getting into this self-correction loop for technical tasks.
How so?
Well, benchmarks like SWE Bench, they were introduced just last year specifically to push the limits of these advanced systems. And they're already being, basically crushed.
And it's not just coding, right? It's also about acquiring high-level knowledge.
Exactly. GPQA, another tough benchmark, measuring sort of general-purpose quality assurance. Scores jumped nearly 49 percentage points there, too. The models are just, getting smarter, faster.
But that speed, it comes at a cost.
Yeah.
Huge cost, right? It needs massive resources.
Massive, and that feeds right into the whole geopolitical and economic picture. The report shows this relentless upward trend in model scaling. The compute, the raw processing power needed to train these big, notable AI models, it's doubling roughly every 5 months now.
Wow, 5 months. That's acceleration we haven't really seen since, the early days of Moore's Law and computing.
Pretty much. And it's not just compute. The amount of data needed, the dataset sizes for training these huge language models, they're also doubling fast, about every 8 months.
So this incredible demand for resources, for compute and data, that's really shaping the global AI race that the report maps out.
It defines it, really.
Okay, so let's look at that race, R&D specifically. The U.S., it seems, still leads in just the sheer number of models being produced. That's got to count for something.
It does. Quantity matters. In 2024, the report says U.S. institutions put out 40 notable AI models. That's way ahead of China with 15.
Yeah.
And Europe lagging with only 3 combined.
40 versus 15 and 3. Okay.
But, this is a big but, we need to look past just the quantity. The really interesting shift is in quality or performance. China is closing the gap incredibly quickly on some key benchmarks, like MMLU for language understanding and human evil for coding.
How quickly?
Well, differences that were pretty significant, like double digits just a year or two ago, they've shrunk down to almost parity in 2024.
Huh. So, okay, if Chinese models are catching up that fast on performance, but the U.S. is pumping out 3 times as many models. What does that mean? Is China struggling to turn research into actual products, or is the U.S. just more focused on, getting things to market?
That's the million-dollar question, isn't it? It seems the U.S. leads right now in deployment, in that sort of front-end innovation people see. But then you connect it to the bigger picture, the long-term stuff. China is way ahead globally in AI patenting.
Discounting power, right?
Yeah, as of 2023, China accounted for almost 70%. 69.7% to be exact, of all granted AI patents worldwide. That could be a massive structural advantage down the road.
That economic and geopolitical tension, it kind of mirrors who's actually building these things, right? Industry versus academia.
For sure. Industry's dominance in creating the big frontier models has become even clearer. Almost 90% of the notable models released in 2024 came from industry labs. That's up sharply from 60% just the year before.
90%.
They have the compute, they have the data access. It makes sense. But we shouldn't count academia out. Their role is still vital.
How so?
While industry is building and deploying these giant models, Academia is still the #1 source for the most highly cited research papers, the top 100 stuff over the last 3 years. So the fundamental breakthroughs, the core ideas, they often still bubble up from university research.
Okay, so academia sparks the ideas, industry scales them up. Where are we seeing the biggest, practical impact of these ideas right now?
The report points heavily towards science and medicine. This is where things get really interesting. Oh, absolutely. AI isn't just a tool anymore. It's getting top honors. You had 2 Nobel Prizes recently that recognized work directly underpinning deep learning and, crucially, its application to things like protein folding. That's huge.
Yeah, AlphaFold and all that.
Exactly. And in the clinic, AI is starting to demonstrably surpass human performance in certain areas. Take MedQA. It's a benchmark based on medical board exams.
Right.
Performance on MedQA shot up by 28.4 percentage points just since late 2022. The best models now, like O1, are hitting scores around 96%, almost perfect.
The idea of an AI acing a medical board exam is, well, it's mind-boggling. But what really struck me was the study on human-AI collaboration. You mentioned GPT-4 outperforming doctors on complex diagnoses.
It did in that specific study, yes. But perhaps more importantly, when doctors use GPT-4 as an assistant for complex management decisions, not just diagnosis, but figuring out the treatment path, their overall performance improved.
How much improved?
By about 6.5 percentage points. So it points towards AI as this incredibly powerful co-pilot, augmenting the physician, not necessarily replacing them, especially for that high-stakes, complex work.
Okay, so we have these incredible gains, especially in knowledge-based tasks. But there's a tension here, isn't there? Because the report also highlights these persistent blind spots. AI is great at knowing things, but struggles with reasoning and acting autonomously.
That's the crux of the limitation right now. Yes, models can tackle things like international math Olympiad problems now, which is amazing progress. But ask them to do complex reasoning that requires structured multi-step planning. They really struggle.
And the data backs that up.
Clearly. Look at a benchmark called PlanBench. It tests these logic puzzles that need, say, 20 or more steps to solve correctly. The absolute best model, O1, only solves about 23.6% of those.
Less than a quarter.
Yeah. It's like they can memorize the map of the world, but they still get lost trying to figure out the path of a marble rolling through a complex maze step by step.
And this limitation, it directly impacts this whole area of agentic AI everyone's excited about, right? These autonomous systems that are supposed to act for us.
Exactly. Scheduling flights, managing workflows, there's a lot of hype. But the report includes a reality check from a new benchmark, the Visual Agent Bench, or VAB.
Okay, tell us about VAB. What is it testing?
Think of VAB as a really complex obstacle course for AI agents. They have to interact with websites, understand visual information, complete goals that have multiple steps, basically act semi-autonomously in messy, real-world-like digital environments.
And how did they do?
Not great, frankly. The top model tested, GPT-4o, only managed an overall success rate of 36.2%.
Just over a third.
Right. And the conclusion from the benchmark creators was pretty blunt. Current AI models are, quote, far from ready for direct deployment in these complex agentic roles. The failure rate is just too high for uncontrolled situations.
That's a really stark contrast. Lightning speed on knowledge tasks, but major roadblocks on reasoning and reliable agency. And kind of underlying all this, there's another growing problem the report flags. The data itself. The data commons is shrinking.
Yeah, this is crucial and maybe underappreciated. These models feast on vast amounts of public web data. But website owners are getting nervous, legal worries, copyright, just a drain on their resources, and they're increasingly blocking AI scrapers.
How widespread is this blocking?
It's accelerating fast. The report looked at a big data set called C4. The proportion of data points or tokens that were restricted that couldn't be scraped jumped dramatically. It went from maybe 5-7% in 2023 up to somewhere between 20 and 33% in 2024.
Wow, up to a third of that potential data is now off limits.
A huge chunk of the open internet is basically saying keep out to AI training.
So, what does that mean long term? If the fire hose of high-quality public data shrinks like that, does the whole scaling paradigm that's driven progress eventually hit a wall? Do we need more synthetic data? Or do models just become smaller and more specialized because they can't get enough diverse human text?
That's the big looming question for developers, I think. This scarcity of genuinely diverse, high-quality data could easily become the next major bottleneck. It might force some fundamental changes in how models are built or trained, maybe sooner than anyone expected.
Okay, that really sets the stage for our next section. responsible AI, or RAI, and all the challenges of actually getting this stuff safely into the real world. Because even the best models, the ones designed to be unbiased, like GPT-4 or Claude 3 Sonnet,
Yeah.
they still show implicit biases.
Oh, absolutely. It's a really tough, persistent problem. The bias is just baked deep into the massive data sets they learn from. So the models end up reflecting and sometimes amplifying societal stereotypes.
Like what kind of stereotypes?
Things like associating women more with humanities fields than STEM, or tending to link men with leadership roles. Trying to build an AI that's truly impartial, free of these embedded societal biases, is proving incredibly difficult.
And then you add the whole security dimension, especially with these agents we were talking about. The report highlighted something called infectious jailbreaks, which sounds pretty alarming.
It is alarming.
Yeah.
This is where the agent's autonomy becomes a major vulnerability. The research showed that if you inject just one cleverly designed bad input, like an adversarial image, into the memory of one agent in a system,
Just one.
one single poisoned input, it can cause this rapid cascading failure across the whole system if the agents are connected or collaborating. Harmful behavior spreads like a virus from one compromised agent to the others.
Yikes. Okay, so the risks are clearly escalating. Is global governance keeping up? Are governments reacting?
They're definitely reacting with increased urgency. You're seeing much more intense global cooperation. It's clear this is a global challenge that outpaces any single country's laws.
What kind of actions are we seeing?
Well, there's a flurry of new frameworks focusing on transparency, on accountability, trustworthiness. You've got the OECD, the EU with its big AI Act, the UN, even the African Union stepping up. There's a unified push to get some guardrails in place.
But there's always a but.
Yeah.
Getting those guardrails implemented by actual companies seems to be hitting roadblocks.
Exactly. There's this gap between the policy ambitions and the on-the-ground reality. When companies were asked about barriers to adopting responsible AI practices, what do they cite most?
What were the top reasons?
Number one, at 51%, was knowledge and training gaps. They just don't have enough people skilled in how to actually audit and implement these safety measures. And number two, at 45%, was resource or budget constraints. It costs money.
So global frameworks are being written, lots of urgency at the policy level, but the actual companies doing the work are struggling with skills and funding to implement them. That sounds like a pretty significant systemic weakness.
It really is. I mean, if half the companies feel they can't properly train their staff or afford the necessary checks for responsible deployment, you have to wonder how effective these regulations can truly be, at least in the near term. It leaves a lot of room for risk.
Okay, despite all these governance challenges and risks, autonomous tech is rolling out physically in the real world. Let's talk self-driving cars. The safety data from systems like Waymo was actually kind of surprising.
It was surprising and really significant because it kind of pushes back against the constant narrative of fear around autonomous vehicles. The data showed Waymo vehicles had an 88% reduction in crashes reported to the police compared to human drivers.
88% lower crash rate in the areas they operate.
Yeah, specifically in Phoenix and San Francisco, where they had extensive operations. It strongly suggests that, at least in certain complex urban environments, these systems, with their predictable rule-following behavior, might already be measurably safer than error-prone humans.
That 88% number is huge. But the report cautions about reading too much into that, right? It's very localized data.
That's the critical caveat, yes.
Yeah.
The report is clear. You can't just extrapolate these results everywhere. Safety performance depends hugely on the specific environment, the weather, the operational design domain, as they call it. These cars perform well where they've been intensely mapped and trained.
So great results in Phoenix, but maybe not ready for a blizzard in rural Montana yet.
Exactly. But despite those localized limits, the global rollout is pushing ahead rapidly anyway, especially in China.
Right. China seems to be leading the charge on testing.
Yeah, they're rolling out driverless cars across 16 different cities now.
Yeah.
And in many cases, the robotaxi rides are actually cheaper than getting a ride with a human driver.
Cheaper already. That's a powerful economic driver for adoption. It feels like the tech is just going to push into the mainstream, and regulators globally will be scrambling to keep up.
That seems to be the dynamic, yes.
Yeah.
Economics often forces the pace.
Okay, so wrapping up this deep dive, it feels like we've surfaced, what, 3 key tensions really defining AI right now?
Yeah, I think so.
First, there's that incredible speed in technical stuff, knowledge acquisition, versus these stubborn limits in complex reasoning and reliable agency.
Right. The knowing versus the thinking and doing reliably.
Second, the geopolitical race, particularly U.S. versus China. It's like U.S. quantity and deployment speed versus China's potential long-term advantage in patents and maybe catching up fast on
And
performance.
very dynamic competition there.
And third, this big gap between the real urgency we see from global regulators trying to set rules and the very real practical barriers, skills, money that companies face in actually implementing responsible AI on the ground.
Policy ambition versus execution capacity. That gap is crucial.
And maybe one last piece, just zooming out to public opinion. How are people feeling about all this?
It's interesting. Optimism is still incredibly high in places like China. 83% feel positive about AI's impact. But what's notable is this shift in countries that were previously more skeptical, like the U.S.
What's happening in the U.S.?
Optimism there has actually increased significantly. It's now at 39%, which is up 4 percentage points just since 2022. So maybe as people interact more with the technology, some of the initial fears being replaced by, well, cautious optimism, perhaps.
Yeah.
The public is definitely grappling with it.
Okay, and that grappling leads us straight into our final provocative thought for you, the listener, to chew on. We talked about AI agents. We know their success rate on tough, comprehensive benchmarks like VAB is still really low, that 36.2% number.
Pretty bad, yeah.
But despite that low reliability and complex tasks, these agents are proliferating. We see it with self-driving cars, rubber taxis. They will be operating autonomously in the real world very soon, if they aren't already in some ways.
And here's the kicker from the research. Remember the infectious jailbreak idea? Well, related work found that it takes surprisingly little effort to break an agent's safety programming, just minimal fine-tuning, like 6 specific steps in one experiment.
Just 6 steps.
Yeah, tiny tweaks. And it could dramatically weaken a model's safety alignment, causing the rate of harmful outputs to jump from, say, a manageable 1.5% right up to a catastrophic 87.9%.
Okay. So you have agents with known reasoning flaws being pushed into the real world, and we now know their safety features can potentially be incredibly brittle, easily broken with minimal effort.
That's the setup.
So the question we leave you with is this. Given that fragility, and given the unstoppable push towards autonomous operation in uncontrolled environments, how fast do governance frameworks, the rules, the testing, the oversight need to evolve to even hope to manage the inherent, escalating, and apparently easily exploitable risks of these systems?
How fast can we adapt when the tech is moving at this speed, and the failure modes could be so severe?
Something to think about. Thank you for diving deep with us.